So we developed a language which we call otto programming language, because there exists a word Otto Normalverbraucher in German, and this means this is the ordinary consumer of Germany. That means it is a language for every people. Here we use the plus, this is Otto. And it started from SQL, and now you can also say that this is table-oriented programming or tabelorientiert programmering. So this is what I want to speak about. I have some tales. This is the contents in short. And I have 1 hour. And here is a sentence of Merkel. I believe that the ability to program will be one of the basic skills of young people besides reading, writing, and calculating. She repeated this sentence at least 6 times, and I read some papers who spoke about this, and the journalists had some problems. What did Angela Merkel mean with it? Which programming language can everybody understand, or to which degree? And I had the impression nobody understands this sentence from Merkel. And I believe she was in Estonia and she was very impressed, and therefore she made this, she takes this requirement. And we think programs in table-oriented programming language Otto are very compact, are very well readable. Therefore, it seems that Otto suits good for school. And I hope that I can present some of our basic ideas. And we believe that the great part of the language belongs to mathematics lessons in the same way as the operations of the pocket computer belong to the mathematics, because in mathematics you learn addition, multiplication, sign function, and so on. And in the same way, I'm also a mathematician. A lot of this stuff can be realized theoretically in mathematical lessons. And we believe that the end user of future can formalize his queries and programs by itself. And even I hope that it will be clear that non-computer scientists can program their own apps. I will present some example. And further, we have, I believe that behind every content click should be a readable program. And I think this is very important to understand the result of the computer, and then it is a great advantage if you can follow the calculations of the program to better understand the computer. Everyone should know mass data operations analogously to plus, multiplication, and sinus. The school should offer computing with structured tables and documents. This would be very nice, and the basis should be algebra, and we think many people think in algorithms. And further, repeating groups or hierarchies we think are very natural. And I show some programs where we don't need iteration, we don't need general recursions, we only have very simple programs which can be represented only by sequences. And nevertheless, we think our language is expressive. Also, we have a very simple program structure because we have very powerful operations. For example, we believe that we can omit if we want, or from the other side, if we want new contents in the school, we have also to put something out of the curriculum. That means, for example, I believe it is not necessary to teach the division algorithm for decimal numbers, or it is not so important, I think, to teach Excel. And on the other hand, I believe also object-oriented programming has some problems. Also, if you have small problems, you need a lot of lines of code if you use an object-oriented programming language. And therefore, I believe also that it is not so important for broad user classes to know object-oriented programming languages. This is a question of informatics students, for example. And here is a very old citation of Dijkstra. And I also met Gerard Huet, and he developed the language Camel, and he also told me that object-oriented programming didn't realizes the aims they originally had, namely that programming the modularization of large systems can be better done by object-oriented languages than in older languages. Also, I will say a sentence of Bill Gates. He said that in programming languages there is no great development in the last 30 or 40 years, because the programmers now are not very much quicker than the programmers 30 years ago. That means, and I also believe in this way, and so I think we need better programming languages, and especially we need programming languages for the end user. And I have a very small problem. What is 12 divided by 5? Or you can, if I speak with preschool children, I would say share 12 apples on 5 children. And I made it with my grandchildren. They are not able to understand the result in natural numbers, that the result is 2 raised 2. And if you want that your children will understand that the result is 2.4, then you have to teach several years. But nevertheless, I think preschool children are able to solve this problem. And they make it in this way. I realized it with choco lenses, and these are the names of my grandchildren, and they all come to this solution. What does it mean? This means they can divide without learning anything. Yes? And for me it is difficult to understand what they are doing, because we have a language which basically works with tables. So I omitted this. I put it here some photos of the children, and then they divided these choco lenses. And then we have to abstract by this bar, and then you can say this is the result of 12 divided by 5. So I add one, to understand this, I add one column name. But if you consider, for example, SQL, then you need here also a column name. Or it is unclear what is going on. You can also say you have one column name for this column, you have column name for this, and if you add several bars, then you have a new column name. But in SQL, you can't introduce such a column name. That means this simple algorithm is very complicated if you restrict yourself to the programming language SQL. So, and the thing is that SQL uses only a very so-called flat tables, and we use structured tables. That means we say the result is not a simple table, but a structured table. And this L is an abbreviation for list. That means we have a list of children, a list of child, and for each child we have a list of apple. And also it is not possible to introduce in Excel such a scheme. I will show that we can work with tables, with structure on a high level, with tables which are structures in this way. We have a relative universal data type. We have, for example, a word as data type, and I know no other language which has such a simple data type word. We have a data type bar, as you have seen there, and this is a thing for a simple number, and this is the oldest data type of mankind, I believe, the simple bar. And I believe it would be good if very young pupils work with this data type, that they work with tables where they only calculate with bars, and so on. And then we have several types here, two number types. Then important is what is a tuple. We have set, multiset, back is the same list, and this is something like a repeating group. And if you have a value and a repeating group and a tuple, then we call this tupment. Here it is the word table, and document. We created a new word and we say these are tupments. Here you see it once more, and the last is only for performance reasons. And here you see one table, and this is a structured table. This is, for example, we have a set, a menge of names. Each name has a class, and then we have a set of subjects. Here I wrote only several subjects. In reality, they have more. And then for each subject and each name, you have a list of exams. And in Germany, there are only 2 exams in 1 year. That means this is a very small list, but you have a long list of marks. And this is a structured table for us. And we shall see that we can, for example, compute the average for such, the weighted average for such tables with very short programs. And if you want to put this information in the relational database, you have a lot of troubles. You have to split this information in several tables. You have to join the tables, and it is very difficult to compute the average for each name or each subject or something like this. So now I will give you an impression of our system, how it works nowadays. We have the aim also to improve the pocket calculator. That means you can, for example, write such a simple expression with brackets. You can click here, and I hope this is the correct result, but I will show you that you can also omit these brackets. and you get the same result. Yes, you see 21. And this is because this operation multiplication takes the argument, that means has the input is the result of the former line, and then the second argument is what you write here. So you don't need brackets, and you can calculate, for example, this simple problem. And also you can add new things. I will show you another thing. You can type such a list of marks. Maybe we add one again, and you see you have a list of marks. Here we don't see the data type, but this is a list, if you have seen, if you represent it by this. And I have chosen a German word for this data type because the English word is longer. You can also choose the word number, but I want compact programs and compact outputs, and therefore we have now here a German word, but I hope it is not so important. And if you want to create the sum, you get this, you get 11, or what is more interesting, if you want to compute the average, you can make it in this way. I teach this language also not only in German gymnasium, means this is a higher level. I taught this also in ordinary school, and I must say I have really a lot of problems that the pupils are able to remember such a simple abbreviation, average. I have to tell it 10 times and 20 times, and some pupils are not able to remember that you have to type AVG to get the result. Yes, so I believe that you will have some problems to teach also such simple programs in school. You can also multiply this by 1.19, for example, and then you get a list of Zahl with point. That means this. If, for example, this are let's say net prices in Germany, we have taxes 90%, then each net price is converted to a gross price. Yes? And so if this is the rate for a currency conversion, and these numbers represent, for example, maybe these are two simple numbers. Maybe you have here more complicated numbers. And then I have no time. Then this represents, if this is the currency dollar, this is the currency euro, then you have, by typing this number only once, you have all numbers converted to euro, for example. That's up to you to interpret these numbers. So we can make also more complicated things, but if we want, for example, here a table as input, we have nowadays to type this word, and then I can say let's create a table. You only have, this is a flat table, a list of pairs, and let's say we are sitting in a restaurant and one beer costs something. We have some children, they are drinking limo. Let's say this is the price. Let's say we have, and let's say it is a little bit more expensive. Now, this is not a nice table, it's quite clear. If we use this representation of Tubmans, then we have to improve this. And we can realize it by a very simple editor. And you see, if you look to the result, nothing had changed. Only the tags are omitted. So now if you are interested how much costs is this in a restaurant, then you see you have to pay 3 mark or 2 euro, it's up to you. And you can apply this sum also to a whole table. I think this is very convenient, but the reality is more complex. If we have, for example, ordered 5 beers, 4 limos, and several schnitzel, then it's okay. This number makes no great sense, yes, because this is a sum of all numbers which are contained in this table. So you can say, I'm only interested in the sum of the column price, then this is smaller, but this is also not what you are interested in. But you can type price, and the second argument, that means the second input value of sum, is now an expression, and you see you have to pay 11 euro for this bill. Yes, but we want to make it yet more complicated. We define a structured table. That means we have ordered not only 5 beers, but we are sitting more time. We have 7 beers, 8 beers, 4 beers. And then I want to show you that you can use this also later on smartphone. That means if you have a long number of orders, you can also introduce a new column, and the system understands this. Maybe this. And now you get the result in such a simple way. Also, the input table is a structured table and is relatively complicated, I can say. You can also I introduce a new column name, and then you can see what is the result. And here you see that is a real structured table where the numbers are nominally written always in a new line. And here you see the calculated value. For example, this value results from 7 multiplied by this number, and you see you don't have to repeat this and you get the result. That means if you want to solve this in Excel or something like this, it is not so easy. You have to think several times. Also, if you work with Excel already several months or so, you can't write such a simple formula. You have to type one formula, then you have to copy it, then you see you have a new number, you have to type the formula again, because here's a new starting point, and you will have, if you're not an absolute expert, you have a lot of problems and you have a lot of formulas, and here you have only one expression, and this is done by the system which calculates these things. And therefore I think we have some advantages, and further compared to Excel, and further a great advantage is if you only want to solve this problem in Excel, you have a lot of formulas in Excel, and if you don't have written this program, it's very hard to understand for another person to understand the Excel program. What is the program computing? And here you have one line. You can think about this line. At the first step, you have to learn a little bit what is going on. But if you have learned it, you can catch very quick what the program makes. And this is what I mean. We want to write user-readable programs. Now I have some programs prepared which are from mathematics lessons. You can click, for example, load, and I have this program with averages, and here you see I have some persons here. For example, Cantor. I studied at the same university at which Cantor developed set theory. I gave the guy some marks. It makes no sense to give Einstein only once, because then you don't have to calculate an average if we have only once. And here I want to show you this very simple program. You have to learn a little bit, but if you understood the things, you can catch the meaning of the program in minutes, I believe. For example, I want a set of names, and for each name a set of subjects. And because I have written an M and not a list, this result will be sorted. If I choose an L, we have no sort, and then also duplicates are eliminated, because in each set, each element occurs only once. And here's the same. The subjects are sorted. Here you see German and so on. And then I introduce a new column name. I take a short word because I wrote it 3 times. I have not too much to type. And then I compute the average in the sense of Germany. Namely, I say I have to compute the average of the list of the exams. I multiply it by a number. I have to compute the average of the list of marks. I multiply it by another number, and then I take the average of these 2 averages, or let's say of these 2 numbers which we compute here, and then we get the total average, the average per name, and then the average per subject and name. And you see, this is the result, and this means I round the result to 1 digit after point. That means so you have not so much information, because if you have always so long floats here, so long numbers, it's not so nice to see what is essential here. You can also consider more complicated tables. For example, I'm interested in subject and also the average, and you see you get an additional table. That means one query. This query here, you get a table, and then you get one table more, and this is the average, the total average per subject. And here this is the average for of the subject for each person. So the teacher can get very compact informations of his pupils, and he can understand the program. If you write this program in SQL, you need hours or days to write down this program. This is what I believe. Because you can't query on one single table if you want to solve this problem. You have to join the data, and you have a list of marks, and the mark may be again the same. You can have for one person and one subject several times a one, and if you say this is a set, then the duplicates are eliminated and so on, and there will be a lot of problems. So let's look to another problem. BIP point. Otto, for example, this is, as we hope, a very simple kind of recursion. This is a comment. This is a comment. I can change this. Then this is the result. We have one condition less. We can also omit this, and you get the same result. And what does the table realize? You have here some input data. This is given, and then we compute new columns by 3 lines, and we say, for example, for China, this is the increase of BIP. And you see they start from 100 and they reach this number, East Germany this number, and West Germany this number. But if we make again a comment line, then we get completely other statistic. Namely, now we start already at 88, and say here we start by 100, and then China has a raise to 1,000. That means the factor 10, and West Germany in this period have an increase of 50%. East Germany looks not so good, but what is the computation? I think it's very simple. We have here this column, and in the first element in the new column is 100. That means we start by 100, and then we say we take the predecessor of China. This is the column China. That means this number, and then we multiply it by this number. This is the increase of China divided by 100, and 1 plus this. That means 100, here is China, 4.2, and we get this result. Then we take this number, we apply the same formula, and we get this number, and so on. This makes the system. So this is a very simple program and a very simple kind of recursion, and I hope that you can teach this to everybody, if everybody wants to understand what is going on. And the interesting thing is, I believe that here we only have to understand what is addition and division. And you don't have to understand what is an exponential function, and nevertheless, you can program this calculation. Also, if you don't understand what is an exponential function, you only have to understand what are the basic operations which everybody learns in the first 5 years. Let me give a very small program. here we generate some numbers, and then we extend this for each x value, and then we have a formula which copies a whole set. I will not go in detail, maybe we have to, but the result is a large table. And then I had a student, I said to him, make nothing else, nothing more than writing each point which is given in the table. And then I wrote a program which, oh, it's not so easy, which can calculate the Estonian flag. And I must say, I made an error. I looked to our Wikipedia, and then I did not recognize that there is also a white part of this flag. So I have here only 2 parts, R1 and R2, and the white flag, the white part is omitted because I didn't know it. I can't realize this on this Wikipedia, because the background was also white, and I thought this is the Estonian flag. Excuse me very much. And then you have only to give this set a color, and this set a color. You have here a set of points, and the system shows every point, and then you can get such an image. And here you see red, green, blue. And I want to show that if you want to make such things, you can also, with set-wise operations, compute a little more complicated things. And I think pupils will like to make such things. Here I have a line which is a circle, and here an inequation. That means I select some points, or you can say I delete some points, and so you get a new image. So it is a nice application for the equation of the circle, and simultaneously an application for Ungleichungen, unequations, and so on. And then you have here 3 colors, and then you have a very small program, and here you can apply sine function and so on. But if you want to make it so, you have to test it, and maybe you have to change the number several times, and then you will get such image. And this implemented a student, and maybe this program for visualization took only 1 month. Our system as whole, you can say, represents 20 or 30 man-years. That means we work already a long time on this, but only very few people. In the meantime, only 1 person was working on this system, and we have no really power up to now put on these systems. Nevertheless, I think because of this, we are not able to go to industry and to say, please, Siemens or some big company, you can use this, you can make this and this. I think they will not accept us, because we are up to now not able to ask, for example, their Oracle databases or such things. We need some money to build an interface to these things, but this is not so easy from my point of view, to get money for such a project. And therefore, but on the other hand, I think, I believe I showed you already, you can use it already in school. because you can solve such a lot of problems of mathematics lessons and of computer science that I believe it's very useful in school, and you can use this already now, I hope. I will show further programs. Here, for example, very simple things. Oh, excuse me, I forgot to translate this to English. Compute integer nulls of one polynomial. You only create this number and you see solutions are 7 and 8. I think this is a very simple kind of computing, and where you don't have to think deeply. You can, in many situations, you can solve problems without deep understanding of mathematical formulas. And I have further examples. For example, a simple null, an approximation. Here I have an English text. Computes the null of the sine function in this interval in a very simple way. I generate very many numbers from 3 to 4. In this step, I say all the numbers, the sine function is smaller than 0. I take only one element, and then I can compute it. And you see, you have a good approximation of the null of the sine function in this interval. That means you don't have to learn some iteration or something like this. So also the end user is able to find with very simple with a very simple program what is a null, what is an approximation of a null. And there I have, for example, derivation. Here you can compute a table where the derivation for each x value is calculated. Then you can show the image. You see here, you can illustrate this derivation of sine, and in the same way you can show also the sine function. You can make colors if you want. I showed you already, therefore I don't want to repeat this. What is an integral? And here you see another thing. What is the most simple program to compute an approximation of an integral? And how we compute the area of the unit circle, that means the circle of radius 1. We generate all x values of the circle. Here we have already a very large number of x values. Then we compute the height, that means from this actual value, where is the circle, which is the height. Then we compute a rectangle. Here we have a 2 rectangle times the delta, and then we sum the rectangle, and you see you can compute the integral. That means you know this is p. That means a very simple program can compute an approximation of p, and you can illustrate this also. And it is clear you need in school some hours to explain this, but you can also make shorter programs here. You can combine several lines to one line, but the thing is we want to make the programs readable as good as possible. That means for us not the efficiency is the most important thing, but or the performance for us, we like to improve the methodology of the programming. The interesting thing is for us methodology, and therefore we have here more lines than necessary. So in the same way, you can change the program, and so you write here sin of x, and then you change it. I want the sin function from 0 or 0 to pi, and now I want only from beginning from 0. You can compute an approximation of the area, and maybe you know that the correct result must be 2, and so you can change the program. And so I believe that the application of the integral calculus can be taught in every school, because I believe if we have good teachers, they can make this clear to every pupil who visits the 10th class. Yes, it's not necessary to go to the 12th class. I think if you have an area under the curve, this is an important application, and I think this would have some advantages. So we have no more time. I will only show you that we have also other things, that this language is not only for school. That means we are looking for applications in business, and I have here again only students, but you can consider any applications. So I have no time. I wanted to show something more. I must be quick. You see here you have a structured table and one additional table, and now you can query a whole database. And this I can show you only very quick. You can, for example, write, I want all records where the word earns occurs. And you see you get one record. You can also write, I have not the time to go in detail. And now you select only in the tables where the name occurs. And now you can, for example, write very simple programs, give a set of DIN. We have to look how it is written. It is English, so I have to write this. And I only want a very simple example for each dean, all his students, or maybe there's only one student. Let's take another thing. Let's take courses. Now, it's also not a nice example. Then you will see nothing will result for courses, but if you change the operation, I cannot explain this in detail, but you will see, this column is not contained in the student columns. You don't have to write a join condition. The system joins the data, and the user only has to write the head of the table he is interested in. And so we can query whole databases, and not only query to 1 or 3 tables. We can realize tables to one database, and this is, I think, also an important application for databases. And what I want to show, I can give you further examples, but I want to give you an impression of our basic algorithm. which is behind this word GIP. This GIP is again a German word. If we develop our system further, maybe we can omit also this GIP, because I observed that also such simple names make some problems also with German pupils. Therefore, I omitted here a keyword for introducing a condition to make it simpler and simpler. Yes, and now I want to show you what is restructuring a given table. What is the basic algorithm? And now we assume we are standing on the street and we want to count some cars. And we are interested not only in a simple table, but in a structured table. That means, assume at first a VW is coming. We write it in this column. We make here a bar and assume it is a Polo. We make a bar here. Assume a Hyundai is coming. We look in this, we see Hyundai must be in front of VW. So I have to write Hyundai. There must be some letter of this kind. I write this, and then I make a bar, and I have an E30, and I make a bar here. And now assume again a Hyundai is coming. I make a bar here, and let's say it is a i40. Then I compare i40 with i30, and I introduce a new line. And then I make a bar here. And now assume there is some very old car coming, IFA, and this is my car. I need too much, it's too small. So assume this is Trabant. I make one bar here. And these are my cars I had. And then assume now it is coming VW. You compare VW with this. You see VW is greater. You compare it with this. You jump to this and you see you have VW exists already. You make a bar here again. And now you assume this is not a Polo, but there exist also Golfs in Germany. And you make a stroke here. You can make this 1 hour or longer. So the interesting thing, what is going on? I think this algorithm is a little bit similar to the division algorithm. We have, what has the user to do if the system generates this table? He has only to write, I'm interested in a table with this head. I have to introduce a new column name. Let's say NN, I have no other name. Let's say we have here the same column name. And then we have to write, I want here for each make a set of types. And then I have to close 2 brackets. And then the main task the user has to do is realize he only has to write that NN is results from counting cars. So, and I don't have the space to write it down here. And then the system realizes this algorithm, and you see it's possible with this algorithm to sort the data in one step, to aggregate data, and it's not necessary to sort the input data. that means the input data are not sorted by IFA, Hyundai and VW, they are unsorted. And if you consider SQL, you need a group by to make such aggregations. That means it is a very, I hope so, it's a very simple way to make aggregations, and you have to write count because other aggregations are allowed too. If we have only count, it would not be necessary to specify a certain aggregation. We have maybe 10 different kinds of aggregations, maximum, minimum, and so on. I don't have the time. And then I represented this algorithm several times, last time at IBM in Magdeburg, and then we had a programmer from Russia who looked to this algorithm, and she started to implement it during my talk, and she don't listen further how I explained the algorithm. After the talk, she showed me the program. I thought about these algorithms several years, and it took me a long time to understand this algorithm. Why this algorithm is for programmer complicated and not for end users. First, you have not only an arbitrary number of columns, you have not only two levels, you have not only sets. You can steer the things the algorithm makes only by changing such a symbol, only by adding a new column name. You can introduce several levels in depth. You can introduce levels on the same hierarchical level. And so I think this algorithm seems to be very simple, but in my opinion, it is very complicated if you want to implement it. And I made the first implementation in PL1, and I wrote a PL1 program which generated another PL1 program which implemented this algorithm. Later, I designed some restructuring tables, and a student from Dresden implemented this algorithm in C. I showed him the restructuring tables, and he believed at first I can implement this in 1 day. Then he said, I will finish the algorithm in 2 weeks, and he needed five months. Every day he worked 8 hours, and then he implemented this algorithm. And after the 5 months, there were also errors in the algorithm. It was not so terrible. But later, we implemented the algorithm in Camel, where I had a student from Belarus, and he was familiar with Camel. Camel is the language of INRIA, and the Microsoft copied this language, and this language now is called F#, and our system is implemented in OCaml, but in my part I wrote, I don't use any object-oriented feature. I only wrote functional things, and it is possible in OCaml to use also iterations, and for me it is a very nice language, and I make a lot of errors if I program in OCaml, but the system, the compiler, because we have a strong type language, find a lot of errors. Yes, if you work with this system, often you get only syntactical error. Then maybe you have some problems. You can send me a mail, I shall answer, but you can also try change a little bit. Maybe you have only forgotten brackets or something like this. And I have the experience. Last week I was in the 5th class. I have not the time to show this app because the time is over already, and the children, they understand really nothing, but they have no fear from computer. They typing and they have some results, and then you need to explain something, but it is a great advantage to work with pupils, also in 5th class. I do not know whether I will be successful at this level. I have to think a lot how to explain this or this at this level, but I think I have to close, and I cannot show the other things I have planned. If somebody is interested in, I can continue this talk. We are here 2 further days. If somebody is interested in, I can make it somewhere and give more examples or more explanations. So I thank you very much. I can show at least the last table. This is not so good. We plan queries to the Wikipedia. There's no time. So I thank you very much for your attention. Here you can test the system. ottoPS, the PS means programming script, on this in the internet. Here you find also in the internet my email address, and I would be very glad if you try to use it. And I know you here in Estonia, there are a lot of efforts to test this or this language, and I hope that someone of you will try to use it. I would be very glad. And you have seen we can use it not only in school, in lessons, but also in administration, because you can query your databases later, and you can write readable programs. And this is very important, because if there are some changes in computing the weighted average, maybe some numbers are changed, then there are very small changes to adapt your system to the new requirements. So thank you again. We have to close. Thank you.